Okay, so Lucas, pay attention, please. Yesterday we looked at angles, and we drew them as very simplistically angle 1, or we had angle 2. Our angles are going to be a lot more complicated now, and we have more angles together, side by side. So we have to have a better way of doing the names. So what we do for the names is we often use the letters that are involved with the lines. So here we have 3 letters. We call this, where the 2 lines meet and form the angle, we call that the vertex. Okay. And so what we do is we can use an angle symbol, and we call it angle A, B, C. So we have the vertex in the middle and the 2 outside letters on the outside. And so now we clearly know which one we're talking about. So if you look at the next example, how to name an angle, we have 3 angles there. What's the very top angle that we have? Angle A, B, C. Plus we have an angle that's on the bottom. What's the bottom angle? You know, it's kind of rhetorical questions. And if I wanted an answer, I'd actually call your name. Right? Like, that's why I never put up your hand in this class, because you're wasting your time. So what's the answer, Zach? CBD. And what do those 2 angles add up to? What's the name of the large angle then? Raj? The whole thing? But we only use 3 letters. So we start at A, we go down to B, and then we finish at D. Perfect. Okay. So what we have is a way, even though we have 3 angles in this diagram, we can name them specifically rather than get confused about what we're talking about. So it's just a system for us to talk explicitly about an angle and directly about an angle. Any questions about naming angles? What goes in the middle? Austin? No. What do we call that part of the angle? No, it's a specific name for it. Vertex. Okay, so the vertex always goes in the middle of the name. So now what we have here is we have a line that touches the circle in those two points. Let's call it A and B. So that line has a special name. It goes from one side of the circle to the other. If it touches the circle, we call it a chord. C-H-O-R-D. It's a silent H. Okay. So we call it chord AB. We write the letters AB side by side, and we put a little line on top. So that's chord AB. Sometimes you don't see a line, sometimes you do. Depends on your textbook and what you're looking at. Then we have a point in the center. We'll just call it C, and C is the center. So we always mark the center with a dot. Okay, it's always with a dot. And then we can tell whether lines go through the center or not. Then we have another little line that goes on the edge of the circle. And we'll call that DE. DE has a special name as well. If it's on the edge of the circle, we call it an arc. So ARC, we have arc ED. And for an arc, we usually put a little rainbow over top to represent an arc. So curved line, which is an arc. Kind of representative of what you see. Chord AB has a line, arc ED has a little arc. Any questions so far? So now we're going to use this information and we start talking about these angles. So here what we have is we have what we call a central angle. And the central angle is angle ABC. Where's the vertex of the central angle? What part of the circle does the vertex touch? Lucas? The center. So the central angle is ABC. The vertex is at the center. So if you hear central, what word are you thinking? Center, right? Central, center. Very kind of explicit. So what we say is we say that angle ABC something arc AC. So what we talk about with angles and circles is we talk that they touch the arc AC. Okay, I forgot my rainbow. Sorry about that. Now, what we kind of do is we say we have a special word for it in math, but imagine if those are the legs other than a stick man, then those would be the feet. And here would be your body, which you'd add in, and then of course your arms and the head. So it's like a little man. What do you think that, what does it look like that man is doing to the circle? Is he kneeling on it? What does it look like he's doing? He looks like he's standing on it. So what we have is we have a special word in math that represents the phrase stands on. We call that word subtend. So we say that angle ABC subtends arc AC. It's a fancy word for saying that it stands on the arc. So you can draw your little feet. Your feet are essentially where's the angle touching the circle. So right this spot right here, that's where the arc is touching the circle. And that's where it's standing on the circle. So we have to be careful that we understand exactly what's going on and where it's standing on the circle. Any questions about the word subtends? Okay. So now we have on the next diagram two angles. What are those angles doing to the arc? Are they kneeling on the arc? No. They're subtending the arc. Right? They're standing on the arc, so they're subtending the arc. So we have a central angle. Who could tell me the name of that central angle? Chris. No. 3 letters, please. D's the vertex. Good job. ADC. Now you could switch around the outside angle, the letters, it wouldn't matter. CDA, ADC does not matter. Okay? So central angle is ADC. And what is it subtending? Mandy? Good. So it subtends arc AC. Good job. Okay. Now we have a different angle as well. We have angle ABC. It's this large one right here. Is that angle outside of the circle? No. It's inside the circle. It fits just inside, doesn't it? Kind of squashed in there, but it fits inside the circle. So an angle that fits inside the circle and touches the edges, we say it's inscribed. So angle ABC is inscribed. Okay, is an inscribed angle. Sorry about my poor English. Is an inscribed angle. And so inscribed is kind of the math word for inside. It's scrunched up inside the circle. The edges are touching. Okay. It also subtends what? Arc AC. Okay. So it also subtends arc AC. They're on the same arc. And we're going to talk about that relationship in a second. Okay. Any questions about central angles? Inscribed angles? Inscribed, they just fit inside the circle. They're scrunched in there. Okay. Going on then. What kind of triangle do we have over here? Equilateral. Who can tell me one piece of information we know about an equilateral triangle? Taylor? Great job. So we have 3 equal sides. Who can tell me another piece of information we know? Simran? Exactly. We have 3 equal angles. So without telling you any information except that we have an equilateral triangle, what's the value of each angle? Julie? The value of each angle? Good job. 60 degrees. Okay. So each angle is 60 degrees. Now we have another triangle. And we're going to see a lot of these guys in a circle. Circles make these triangles naturally. What kind of triangle is that? JC? Not isolate, isosceles. Isosceles. That's a tough one. Isosceles. So it's isosceles. And what 2 pieces of information do we know about that triangle? Janae? Good. So we have 2 equal, and what was a special name for those sides? 2 equal slant sides. So we have 2 equal slant sides. What else do we know then about that triangle? Cole? Do you know anything about the angles at all? Good. 2 of them the same. Which ones? The top one? Slants. We call them something different though. They're touching the base. So we call them base angles. So we have 2 equal base angles. Okay. So what I should do now is I should go and mark my triangle. I can mark these angles being equal by using the angle symbol with a line. What else could I do to show that those angles are equal? Well, I could go and use a dot. Those are the same symbols. What else could I use? Well, I could use open circles, right? That shows that they're equal. What else could I use? I could use little X's. That shows that they're equal. Janae? But I don't know enough information to actually say that yet. I can use an angle symbol with 2 double lines. Okay. Basically, what am I doing? I'm having the angles. Yep.
I was going to say any symbol that's the same.
Exactly. Any symbols that are the same, right? If the symbols are the same, the angles are the same. For the equilateral triangle, usually you just write in the value of each angle, 60, 60, and 60. Okay. And that's really helpful because that's a good starting point to find other angles from. Okay, any questions? We introduced some vocabulary. We have inscribed angles, we have central angles, we have arcs, and we have chords. And we also kind of reviewed our triangle stuff from yesterday. So now we're going to use that as we actually learn stuff that we're kind of required to learn. A lot of background information, isn't it? So here, circle property number 1. Circle property number 1, what we're looking at here is we have 2 central angles on equal arcs. Okay. So we have 2 central angles. What are those 2 angles? Please label them. Go. Two central angles on equal arcs. Slater, what's one of the angles' names? Do you know? Good job, ABC. Providence, what's the other one? Good job, DBE. Okay. So let's focus on that. I wonder what we can say, because there's something important here. So again, central angles on equal arcs are equal. So we can use an equal sign there to represent them being equal. And we can use the rule, write it in words. Central angles on the equal arcs, or sometimes even the same arc, are equal. The angle opens up the same amount. It wouldn't make sense for you to have a smaller angle if it should open the same amount. So we can use that now as our example. So angle 50 opens up to this arc, which is marked as equal to the arc on the other side. So what should be the value of angle 1 now? 50 degrees. It has to be 50 degrees because they're on the same arc. But now we can write that in our diagram as 50 degrees. What kind of triangle is that? Isosceles. Mark them as equal, please. Always mark your radius as equal. Now you can find angle 2 using your isosceles triangle rule. How do we do that again? What's the isosceles triangle rule, Inder? Okay, so 180 minus 50. That's 130 degrees. Why do I divide it by 2? You have two sides that are, two angles that are the same or equal. So I divide it into 2 equal parts. That's 65 degrees. So the base angles each are 65. 65 plus 65 is 130. Any questions? Okay, let's go on then. Now we have circle property 2. So now we have angle B, angle A, and angle B. What we have here is we have 2 inscribed angles on the same arc. That's what we have. Now we just used the one vertex letter, which is not really a good way of doing it, but they did that anyways. So what do you think is going to be about that relationship? Do you think they will be different? One smaller, one larger? Or do you think those 2 angles will be the same? Kind of like the last one. They'll be exactly the same. So they'll also be equal. So you can put down the same symbol inside, showing that they're equal. So the other rule is inscribed angles to the same or equal arc, same arc, are equal. So we can almost make an equation now. We can almost have a left side equals a right side. We can have angle A equals angle B. And you might get equals angle C equals angle D. You might have a whole bunch of them going to the one arc. So you have to be careful and watch where their feet are. Here's the feet of the angles right at this position. If the feet are in the same spot, the angles are equal. If the feet are in the same spot, the angles are equal. So you can use a highlighter or a pencil or a pen or different colors to trace the angle. For example, angle A I can trace using my blue highlighter. And then I'll use my purple highlighter. And I'll start where the feet are. The blue feet are in this position, and the other blue foot's in that position. And therefore, I can see the other angle that's subtending the same arc. Okay. So they're subtending the same arc. So your highlighter can help you. That's why I printed off the textbook pages. Okay, example number 1. So, we're trying to find angle 5. Well, let's trace angle 5. Use a pen or a highlighter, or even your pencil's fine. And if you trace it, there's the feet. The feet are right here. So what you want to do is trace the lines of the other angle that have the feet in the same position. So there's one foot I traced, there's the other foot. What angle is subtending or standing on the same spot? 20 degrees. Right here. This angle is 20 degrees. So angle 5 has to be 20 degrees because their feet are in the same spot. What about angle 6 though? I'm going to start by tracing that angle. So angle 6 is right here. I found where their feet are. Their feet are, there's his feet. He's upside down, standing on his head. That's okay. And so I'm going to take my highlighter, start at his feet, and trace the lines backwards. So what's the angle that has the feet in the same spot? 50 degrees. So angle 6 also has to be the same value. Angle 7 is tough. Is angle 7 an inscribed angle? No. Is it a central angle, understanding that that point is the center? No, it's not from the center. So I guess we're going to have to use our triangle rules then, aren't we? Well, let's see. I know this is 50. I know that's 20. What's this angle got to be? Use your triangle rules. 180 minus. A tinder? What is it? Sorry? What's the answer? Well, what's 180 minus 70? 110. So your triangle rule tells us that value is 110. And so now you can use your straight line rule to figure out the angle 7. So you have to use your triangle rule, and then your angles on a line rule, AOL, or straight line rule. And so what do you get for angle 7? 70 degrees. So 180 minus 110. So now we have to use the rules from yesterday as well. All right, next example. Example number 2. What's the value for angle 4? Trace angle 4 with your highlighter to see where the feet are standing. Okay, the feet are standing on these spots. So then you use your ruler, so your pencil, your highlighter, to trace back the feet of the other lines. So I always go from the feet backwards. And so what other angle shares the same position? 35 degrees. So angle 4 has to be 35 degrees as well. Okay, what about angle 5? Let's find angle 5. Well, I'm looking at angle 5 standing here, and the other angle is angle 6. Well, I don't know angle 6 yet. So I guess I better go back to my triangle rule. Let's work at the triangle, because we can't see any inscribed angles. We don't know it. So Brooklyn, what's the value of the top triangle? Yeah. Can you figure out the top triangle? We know this is 35 degrees. What's this angle over here? Yeah, it's got to be 90 degrees because the other side's 90. So it's got to be 180 minus 90. Use your triangle rule now for angle 5. Use your triangle rule for angle 5. Michaela, what is it? 180 minus 35 minus 90. Pardon me? 55 degrees? Yep, 55 degrees. Okay. So now that we know angle 5, does it help us find angle 6 at all? Yeah, because what are they doing? They're on the same arc. They're subtending the same arc. So they're exactly the same. It's 55 degrees as well. So we had to use our triangle rules to find the inscribed angle, and then we could go inscribed equals inscribed on the same arc. A lot of stuff going on there, isn't it? Okay, so that's kind of grade 9 stuff. Is you're going to have a whole bunch of things to work out. Let's try this example now. This is really weird. We have absolutely no numbers for the actual angle values. But we have inscribed angles subtending the same arc. These guys have their feet in the same position. So what can we say about them then, Chris? Give them an elbow in the stomach. Not impressed. Not impressed. So the feet are in the same position. What can we say about the angles then? If the feet are in the same position, the inscribed angles are equal. So we can say that the left side equals the right side. What's the angle on the left side? 30x minus 60. And what is it going to equal? What's the other angle? Herman? Yeah, 20x minus 30. Now we didn't have to be left side and right side. We could have said angle 1 and angle 2. Basically we're saying those inscribed angles are equal. Can you solve for x now? Yes, you can. So now use your algebra rules, solve for x. Go. Move things across the equal sign by doing the opposite of adding and subtracting. So I'd add 60 first. That would be the easiest. And you get a plus 30. Then move the 20 over by subtracting it. It's not 20, it's 20x. I'm showing tons of work here. What do you get x equal to? Yep. Awesome. Good job, Maddie. X equals 3. Okay. So now we use that relationship to find those angles. Can we actually find the value of all of them now? So we have the angle on the left, which is 30x minus 60. We have the central angle in the middle, which is 20x. So we have the inscribed, we have the central, and we have the other inscribed. And the other inscribed is 20x minus 30. So what I want you to do now is I want you to substitute x equals 3 into each equation and solve for a value. We got to find all three. Okay? So go for it. Substitute x in and find the value of all three. So this would be 30 times 3 minus 60, 20 times 3, 20 times 3 minus 30. Okay, go ahead. solve for them. Let's go. Interesting. 30 degrees, 60 degrees, 30 degrees. Interesting. So, look at the numbers. When we go from an inscribed angle to a central angle, what do we have to do? Going from inscribed to a central, from 30 to 60, what would you do? Multiply by 2. And you do that to the other side as well. What if you're going the other direction? What if you're going from this large central angle to the smaller inscribed? Divide by 2. And you'd have to do the same thing on the other side, of course. So we're going to talk about that. The central angle, the middle one, is a lot larger. How much larger? Twice as big. Okay, so we're going to talk about that relationship in a second. What I want you to do now, here's a full meal deal for example number 4. So you have isosceles triangles, equilateral triangles, angles on a line, all that stuff. Solve for angles 1, 2, and 3. Go. Okay, a lot of this will be based on last night's homework. Okay. So, angle 1. Charn, what's angle 1? You can get it? What kind of triangle do you have? You don't have to do any math for this. Kiana? Angle 1. Yeah. So the first thing, look at my diagram. What did I mark down on these two radiuses? That they're equal. So what kind of triangle is that? Isosceles. So that's 70 degrees. Now, what do I have to mark down over here? That they're also equal. What's the value of angle 2 now? 60. Why? Equilateral. Okay. Notice how the markings between the triangles are not related. It doesn't mean that those base angles are 60. Okay. How do we get to angle 3? Well, if you're stuck, find all the angles that you can. So find all the angles and all the triangles, see if they'll help you out. I'll give you 30 seconds. So this is 60 degrees. This top one over here is 40 degrees. So use your isosceles triangle. All you're doing is using your triangle rules. 60, 60, 60. Now what do angles on a line add up to? 180. So we can go 180 minus 60 minus 40 is 80 degrees. So angle 3 has to be 80 degrees. So it's all stuff we worked on yesterday. Any questions? Okay. Turn it over. So circle property 3. We just looked at this. Angle 1 equals a central angle. Angle 2 is an inscribed angle. So if we're going from angle 1 to angle 2, what do we have to do? How do we go from a large angle to the smaller angle? Mandy? Divide by 2. What if we start with angle 2 first? And we go to angle 1. So we're going from the smaller one to the larger one? Simon? Multiply by 2. Okay? So what I want for the rule, if we go from the central to the inscribed, we have to divide by 2. If we go from the inscribed to to the central, we times it by 2. Okay. Yes? No. We're going from the larger one to the smaller one, we divide. If we're going from the smaller one to the larger one, we multiply. No. Okay, angle. Okay. So let's just look up here. If I am this far away, way up here, the angle's that big. But if I get closer, what do I have to do? I got to make it larger. Okay? In fact, it'll be twice as big. So if you're closer, you're larger. If you're further away, you got to shrink the angle down in order to be on the same arc. Okay, so same or equal arcs. That's what we're looking at. Any questions? Okay, try and figure out angle 1 and angle 2 in the example. Now look at the example, figure out angle 1 and angle 2. Raj, what's angle 1? $70. You multiply 35 by 2. Okay, so here's the feet at the bottom. They're both on the same arc. Okay. What about angle 2? Inder. Haley? Brittany? 35 is correct. Okay. It's on the exact same arc as 35 degrees. Right? The feet are in the same spots. So it's 35 degrees. Or it's half as big as 70. Both work. Both reasons are correct. It worked out perfectly.